Okay, well, welcome and hello to everybody. Welcome to our Cassandra Masterclass webinar. And on this Masterclass today, we will be introducing you to the best practice for robust Cassandra development. I'm Steve Benton. I lead the community engagement for AxonOps, and I'm going to be your host for today's Masterclass. So, AxonOps estimates about 70% or more Cassandra operational issues result from developers not robustly following best practice. And today we want to help ensure that you are in that 30% group. All right. And the topic of development, best practice for Cassandra is huge. And, any one of the tenets could have its own masterclass. And they will, I'm sure, one day. But that said, you will walk away with actionable items and valuable roadmap to implementing robust development best practices. And we're also going to take the opportunity to introduce you also to AxonOps Workbench, which is an open source developer tool currently available in beta and something we feel fills a big gap in the Cassandra toolkit. Now, listen, of course, with any masterclass, we have to have our masters. And today we have one of the finest in the house with us. So let's welcome Johnny Miller. Welcome, Johnny. How you doing?
Good, Steve. Hello, everyone. Nice to see you, hopefully, again from the previous webinar.
Absolutely. Yep. And, if people didn't make it to the first webinar, why don't you just share a little bit about yourself before we get going?
So I've been using Cassandra for a very long time, since 0.6. I think must be at least 12, 13 years ago. And pretty much every system I've built or managed or architected ever since has had a flavor of Cassandra in there. So I've definitely learned all of the mistakes over the years, and hopefully some of the best practices.
Great. Well, it's great to have you back again with us, Johnny. And we're really looking forward to all the great things that you've got to share and demonstrate for us today. So everybody, as I mentioned, AxonOps are hosting the webinar today. And I promise this is the only marketing slide that we're going to see we've got for you. But those who don't know AxonOps unifies the monitoring and operations of Apache, Cassandra, and Kafka via a single intuitive user interface. Now, there wasn't anything really like this around a few years ago, which was quite a big problem. And so AxonOps was built by a team of veteran data platform experts who were pretty much frustrated by the lack of effective tooling. So AxonOps now meets the demands of critical workloads globally across multiple industries and use cases. So there we go, a little bit about AxonOps. But look, it's great to see so many people joining us. We had nearly 100 registrations, which is fantastic. So if you just joined, a special welcome. We are recording the session. We're going to make sure that everybody does get the link to the recording in due course afterwards. Also wanted just to mention that you should see a Q&A on your Zoom. Please feel free to use this. If you want to comment anything about the webinar today, is this helping you? Do you have any questions that you'd like to ask us? We have got a ton of information to get through today, but we do want to make some time for some questions as well. Is there anything, other areas that you want to hear from us as well on? Do let us know. Do interact with us on that Q&A. It'd be really good. Okay, right. Well, why don't we get going? Johnny, why don't you kick us off with our first part today?
Sure. So, why are we on a webinar around Apache Cassandra? It's the first thing to point out. So, there's genuinely good reasons why people choose to leverage Apache Cassandra if you're building systems and using it as your choice of database. It has lots of amazing features, performance. The scalability is off the charts. It's very highly available. There's no reason for downtime in Cassandra. All of the standard operations, rolling restarts, upgrades, all those things, don't need downtime for it. It's a proven technology. It's out there. It's been out there for a while. It underpins some of the biggest critical systems out there. And it's a fully open source and very active Apache Foundation project. So this is why people choose it. But there's a challenge that developers that typically have with Cassandra, and so where do the things go wrong when we developers start to want to use Cassandra? Now, the first obvious thing that goes wrong is often developers are unfamiliar with the technology. They're used to traditional databases. They which leads them to misapplied practices. There's a lot of features and flexibility in Cassandra, and performance trade-offs against features in there as well. They have to handle changes in usage patterns that could affect latency and availability issues. And if they don't get their handle around all that, they get all the things that counter why you're using Cassandra. They experience performance degradation, excessive costs to run. You need more hardware. It's more complex to look after. It's less reliable. You have scalability limitations, and that's basically the development challenge facing people building apps using Cassandra. Now, I'm going to go through a bunch of areas around this, and all of the first section I'm going to dive into is data modeling. Okay, now Cassandra, it's a database, so data modeling is going to be a pretty important feature for it. But why is good data modeling important? So Cassandra, as we all know, highly available, highly scalable, distributed database, no single points of failure. It's just a fantastically reliable database to use. But to achieve this, there's limitations on what you can do when in comparison to a relational database. So Cassandra is essentially not optimized, is optimized for non-relational data models. You can't do joins between tables because joins don't work well on distributed databases. There's no transactions because transactions lock things up. So there's no commit, there's no rollback, these things. And that's how Cassandra gives you all those amazing features, is by not essentially supporting these things. So what do you do? When you come to modeling your data for Cassandra? There's lots of different approaches. There's lots of ways to look at this. And as Steve mentioned, I teach courses on data modeling, so we could be here for days on this. But basically, the simple approach to do with data modeling in Cassandra is you create multiple tables optimized for your queries. And what we do is we call this query-based modeling. And what you're basically doing here is denormalizing your data to different tables, and then you're writing that to those tables based on how you want to read it. But the main point is you shouldn't be afraid of writes. Cassandra is super fast for writes. Right away out of the problem, and you denormalizing and model your data around your queries. So you need to think about it like top down when you're looking at how to start your data modeling. You look at, okay, what does my application do? What are its access patterns? And now I can start designing the data model. Versus what would be a relational approach, which would be very different. You would just be defining relationships and indexes and things like that. So different approach to modeling. Now, there's a couple of key concepts to get across. Otherwise, the other things we discuss won't make sense. So hopefully this is familiar to a lot of people. The partition key. So the partition key on Cassandra is one of the columns on your table. And it's the value of this column on the row, it determines the physical location of that data. And essentially, Cassandra does a hash of that value, applies a partitioning function against that value, gets the hash value back, and based on that, it can deterministically know where to put the data. So it's a critical part of your data modeling to get this partition key right. And there's different ways you can define your partition key. You can define it like that, which is that one column. You can have it like that, which is exactly the same, where the primary key is defined below. And you can also have compound primary keys, where multiple columns make up that partition key. So that's partition keys. The other feature when it comes to data modeling and the primary key is the clustering key. So the clustering key defines the order of the data within the partition, and you can have multiple rows, can share the same partition key, but you would have unique combinations of clustering columns. It's basically your primary key definition. But this is important, and you can define this like here. So the first column here is the partition key. The second column here is the clustering column, again with a composite partition key like that. You can also have multiple columns as partitioning keys, and you can change the ordering you want the rows in there. But the reason this is important, it's to do with when you're doing your reads. So you have to look at modeling your data around ideally around what those partition keys and clustering keys support in terms of predicates. So on a partition key, it only supports equality, so that's equals and in. And on a clustering column, it's equality and range queries also. So if you look at the example there on the right, you've got a table called emp or employee, and it's got the employee city as the partition key and employee salary as the clustering column. And then these are the columns I can use to query my data. So obviously this choice of primary key is really important because it determines the predicates onto which you do. And getting this right is often, that's one of the common mistakes, is that possibly that choice of partition key, that choice of primary key, the way that when you read the data, you haven't got quite right. And that's a common problem I think you come across a lot. Now, if you do get into that situation, there are things you can do. Now, Cassandra also supports secondary indexes. So a secondary index in the traditional secondary index with Cassandra, just like an index on another database, you create an index on a column, and then you can do a query against the value of that column. Now, secondary indexes traditional secondary indexes in Cassandra are not to be used too often. They have issues. They have a significant performance impact on writes. There's cases where you're going to have to rebuild those indexes, etc. But irrespective, you should avoid using a traditional index on, say, high cardinality columns, so for like UUIDs or timestamps or columns that are being frequently updated and lots of table being deleted, or things that have enormous large data sets. So they're there as a tool, and they can help you out of your data modeling problem on the query base. You can use a secondary index, but I would just say avoid them if you can, traditional secondary indexes, and also make sure to use the at least the partition key still in your predicate query, because if you look at say there was a secondary index here on email, well, that query is going to go out and hit every single node in your cluster. So you still want to isolate the query to one replica. You don't want to be hitting every node in your cluster, but it can help you with your modeling. Now, there's actually now in Cassandra, there's a new, I think it came out in 5.0, or was it either 4.1 or 5.0? Apologies, I can't remember the exact version. But they have a different type of index now called storage attached indexes. And these are a lot better than the traditional indexes in Cassandra. And they are there for you to use. Essentially, they have better read performance than the traditional indexes. They support multiple conditions in your queries. There's a lower level of write amplification and reduced memory, etc. So basically, they're a lot more efficient, and I would encourage you to adopt them instead of the traditional ones. And the way you create these ones, if you look at the example on the right, you have a table cyclist semi-pro, and I create an index here, and I basically say create index using SAI storage attached index, and that's it. Apologies, there might be a mistake there. That might be create custom index in the syntax. But anyway, so storage attached index are in there. You can use yeah, it's pretty powerful. It's a great new feature. I think it really does open up a lot of opportunities now around the data modeling in Cassandra. But irrespective, with indexes, there's always considerations to be had. So you should still model your data to avoid indexes where possible. It is much better sorting out your primary key definition, your partition key, your clustering columns, modeling around that, it will be much more efficient. It will be much quicker. It'll be much more performant. You want to model like that if you can. However, if you can't, I would say also use storage attached indexes instead of traditional indexes. Make sure you're only putting indexes on low cardinality columns. You don't, as I said, putting an index on a UUID is going to have a pretty, it's not going to be ideal. You must also make sure you monitor this. So there's a whole bunch of metrics on your indexes that you should be capturing and monitoring and alerting and looking at the performance, the sizes of those indexes in there. And you do have materialized views as an additional option, or do denormalization for more complex queries. And if you look at the example there on the right, you see a bad example of a bad index. So create index on events timestamp. So that would be, that's going to be a really bad index. The other thing that that Cassandra traditional indexes struggle with, if you have multiple indexes on the same table, it won't support that. But if you do need to put multiple indexes on the same table, that's where your SAI search attached indexes are going to be much more efficient to use. But there you go. That's indexes. Materialized views. I briefly mentioned them, and I'm going to try and not spend too much time on them because they're one of the things that I really don't like in Cassandra, but they are there, and it's important to understand them, what they are. So a materialized view is a feature in Cassandra that automatically makes a copy of the data, another denormalizing of the data. Now, if you look at the example here on the right, you see this base table users, and I create a materialized views or users by email, where I select star from users where email is not null, and I define a primary key for that. Now, essentially, this is another table in Cassandra, and what's happening is as the inserts come in, it selects the values of the mutations and updates the view to that. And there's another example in there. So you can see the use in it. So you can then query users by email, users by state of that base table. Now, that sounds great, but there are some limitations, risks around this. The write overhead, it's going to be 2 to 3 times more expensive to write to a table with the materialized views. It really starts to struggle if you have more than one materialized view. I really keep them low. You're going to have additional storage. There's consistency potentially consistency issues when there's node failures. There's a lot of sharp edges operationally around things going wrong with views. And by intent, they're eventually consistent by design. So you might find the base table has been updated, but the view hasn't. Etc. And you can't create them on tables with counters and a bunch of other things. But the point is, there are better alternatives. There are times when you should use them, and there's times to avoid them. The better alternatives is just to have multiple tables. We're using batch statements to write to further denormalizations. CQRS is a great pattern to do this, etc. But if you are using them, make sure you're monitoring them. Look for the update rates, the latencies in the base tables, how you're rebuilding the views, monitor that, the status of it, and consistency levels. But I typically, I will say some of the worst production experiences I've had were with materialized views. So I'm a little bit cautious on them, but and they're still, I think, experimental. So I would personally say, actually, I wouldn't say AxonOps, we would say don't use them in production. But if you have to, they are there. Fat partitions. So a fat partition is a problem that occurs often in Cassandra when too much data accumulates in a single partition. It's particularly common in time series data with poor partition key design. You end up getting unbounded growth within a single partition key. When you have like very low cardinality keys in time, so like year as a key. Now an example there, you see the problem. So I have this table transaction history, and I have a partition key of year. And what that basically means is every single row for the year in this table has to reside under that one partition, and all of the data in that one partition will have to fit on one node. And that's going to basically cause, obviously, issues around that. Now, it causes hotspots. Essentially, you're hammering the same replicas in there. It's particularly an issue when you have small clusters. You experience poor read performance because the partitions must be processed. It causes compaction issues, GCs, timeout errors, reads on reads, things like that. So fat partitions are something to be keeping an eye on. It's probably one of the worst things. Now there's warning signs. If you see your partition sizes creeping up to a couple of megs, millions of columns in a single partition, uneven data distribution. Uneven data distribution is one of the ones that you'll see. Usually you have one node. Why is this one node got a hell of a lot more than the other node? Often it's a fat partition. And you'll see increasing read latencies, maybe specifically around those fat partition keys. To prevent them, think about your design partition even more to give you that even data distribution. Do some thought around the partition growth when you're doing your data modeling. Think, okay, is year for this table a really good idea if we're going to end up with billions and billions of rows in there? But if there's only 4, well, okay, maybe it's not such a bad idea. But importantly, monitor the partition sizes. You should have your instrumentation and monitoring up, capturing the partition sizes. You can mitigate them if you've got no choice. If you can't model your way around it, there's essentially a bunch of patterns, but they essentially, what's common around them is this bucket pattern, where essentially you introduce some form of kind of surrogate bucket key as part of the partition key, which could be like, and if you look at this example for the transaction history, we had a bucket, and essentially that bucket could be a random number between 1 and 10, could be week of year, month, etc. And then we would break up that partition key wider so that the data would be more broadly distributed around. So that's the way you typically mitigate it. Another problem anti-pattern we see is inadequate denormalizing. So you're denormalizing your data in Cassandra. It's not a dirty word. It's a feature. It's intended. Data duplication is expected. It's necessary. We have a right optimized database, and it's in there. But you should look to denormalize your data, and that's a common thing you see. Another one is over normalization, where essentially you start treating Cassandra like a relational database, where you have multiple tables, but essentially requiring you to join. But obviously you can't join at the Cassandra level, so you're going to have to join at the application level, which can be very expensive, costly, putting that all into memory, sorting it, multiple round trips, etc. So it's something you need to look for carefully. The other problem I've seen occasionally, but I think people usually have a handle on it, but it's just something that you don't really want to experience, is inconsistent denormalizing. So essentially, say you don't use a batch statement to write to all of those different tables for you've done, and then one query works, the other queries don't. Well, then they're going to be out of sync. So that's a problem to have, or you make a mistake of bugging your code with update patterns, using atomicity or atomic updates across all the tables, etc. So making sure you keep up to what you're doing on the denormalization. Best practices, essentially duplicate your data based on the query patterns, and create, ideally, the ideal goal is to create a table structure that supports single partition reads. But so you don't want to be going across multiple things, and you want to maintain consistency through, you see here the batch statements in there. So considerations when you start to denormalize: think about the right amplification. You're going to be writing to 1, 3, 4, 10, 100 tables. That will start to get a bit high. So think about that. You are going to have to pay more for storage, but storage is cheap. There will be an impact on compaction, and there's a maximum number of tables you're recommended to have in a Cassandra cluster because of that. There's limitations on the size of batch statements, and also, very importantly, make sure you're repairing your cluster, repairing your data, and it's healthy when you go down this approach, because you don't want to be seeing inconsistencies around it. So another problem I come across a lot on the data modeling is bad time series data models. Example would be you're using the timestamp as the only partition key, which is essentially creating infinitely growing partitions, and you don't think about the time to live of the data, the retention requirements around that data, etc. So inefficient time series data modeling will result in, you get hot partitions, again, uneven data distribution, and often compaction can sometimes struggle when it hits large partitions. And you can see on the right-hand side here, different approaches to modeling kind of time series data. Here you can see, okay, I have a sensor coming in, and I got all the data there for the sensor ID and the day. So that's my partition key. That should be fairly unique. Similarly here, unique partition key, etc. And then I have the timestamp as a clustering column, which means I can run predicate time range queries across the timestamp as a clustering column. So you can see how it works. Another common anti-pattern is collection column misuse. So Cassandra supports collections as a data type. The main issue here is really they're not intended for like enormous amounts of data. They're not meant for unbounded growth. They're meant for hundreds, not thousands of elements. So if you look at the examples here, you've got a bad one on your left here where I have say a social media, it's a post with comments. Well, that list could just grow forever. And then this row would be, that's not what you do. The better approach would be to denormalize it into a table with each comment as on the post ID comment as a row in the database, and similar kind of approach here. So collections are good. They help you for relationships with data, but they should not be huge in your data model. I think that's no, not yet. Sorry. Are we? So next thing to discuss is, okay, you got your data modeling right. Then it's we'll run through this section quickly because but there are other things that you should be thinking about, which is the consistency level of your queries. So you set the developer, you're setting the consistency level for your inserts, your updates, your deletes at each query, and you need to think about this. You need to decide what is the appropriate level of consistency for this, because if you go too strong on the consistency, you will experience performance loss as a consequence. But fundamentally, consistency is key to tolerating failure. And what I think a lot of developers struggle with is this dilemma between having weak consistency but getting consistent data. But just because you're using a weak consistency doesn't mean you won't get consistent data. It's a very simple formula, which is basically the number of replica writes plus the number of replica reads is greater than the replication factor of your key space, will always give you consistent data. So that means you can use weak consistencies like local quorum or things like that will tolerate failure, be more performant than if you did multi-data center queries. So thinking about consistency choice is important. Lightweight transactions. So lightweight transactions is a feature in Cassandra. It's important to call it out. It was built to solve a very specific kind of race condition, which required leadership election. And people were popping in Zookeeper and things like that to handle this. But basically, you can do things like insert if not exist or update if the value is this. Looks great. However, the way lightweight transactions work, it uses a consensus algorithm. So it's very much less performant than your standard inserts or updates. It requires multiple round trips, extra load on the cluster, etc. So they're not to be used unless you really absolutely have to use them. Worth pointing out, in Cassandra 4.1, there's a new implementation of Paxos v2. So if you are using lightweight transactions, you might want to have a look at this and see if you can, the performance benefits give for you. But have a look at it, you enable it in Cassandra YAML, there is a migration path. Speak to us if you need help, but it is available in there for you to use as of 4.1. Batch statements, we mentioned these before. Batch statements are an important part of how you access your data, how you insert your data into Cassandra. Pretty straightforward. Begin batch, insert, update, apply batch, and then that entire batch statement will be applied. However, there are times when you should use them and when you should not use them. So you should use them when you need to maintain that atomicity consistency across different tables. They should ideally be single partition updates, should be small changes requiring atomicity and primarily about cross table denormalization. What they are not for is bulk loading data, okay? That is not what they're for. They're not for processing large data sets. They're not for unrelated data updates, etc. So use them Now, the reason why they can be problematic is basically resource utilization. They require more resources. They consume memory, more memory than individual statements. They increase heat pressure, et cetera, et cetera, et cetera. And there are some size limitations you should be aware of. 50 kilobytes, the actual byte size, maximum number of row statements you can have around 65,000, and et cetera. And also, there's a big impact on the coordinator node to process that batch, and there's network consideration because you're firing this big, huge batch across the wire. Now, the final on the data modeling side to discuss is row caching. So if you're not aware of this, Cassandra has this feature to cache rows in memory. So when you read them, they get served out in memory, so they're much quicker. Great. However, there are times to use them and times not to use them. So a couple of limitations. Obviously, the cache gets evicted as part of the write path in the database. They consume memory. You use them for when you need them, for when you have read-heavy workloads where primarily you're going to be hitting those cache entries. And when to avoid them, when that data has been frequently updated, large rows that are going to take up more memory, etc. But it is really important to keep an eye on the monitoring around row caching if you're using it, because there's no point turning it on and paying the cost of turning it on if you're not hitting that cache. So if you go with row caching, if it works for you, make sure you have the monitoring to prove it's working. And if it doesn't, you simply alter the table and turn it off. Okay, I think that's the end of the first section.
Great. Excellent, Johnny. Well, a lot of information there for everybody. And of course, don't forget, if you've got any questions at all, please do type away on your Q&A box and we'll come to those. But Johnny, you've got more to come, haven't you? There's plenty more to come, but we're going to just, for a few seconds, just have a quick look to see what we got on the question side of things. Now, we did actually have a question before the webinar started from Sander K. He couldn't actually make it live, but he's going to be listening to the recording. And of course, don't forget, everybody, we are recording this and we're going to make that available to you as well. So if you did come a little bit late, don't worry, you can check out the start again on demand. So the question we've got here, Johnny, is this: what tech criteria is crucial in determining the size of the cluster? I would guess it's peak load, but if average and peak load are far apart, e.g. short bursts, which can be 10 times the average, what are the options? Is it putting Kafka in between or something else? Any thoughts around that side of things, Johnny?
Yeah, I mean, there's most of the time so first part of that question is workload the main reason you scale Cassandra? And yes, it can be, but if you do it right, it's predominantly based on data volume or throughput. That you're scaling things up, adding more nodes in there, and usually it's data volume, hopefully, that you're scaling for. If you're having to add more nodes for more requests, then obviously it's not as ideal. But the real root of that question is this type of workload you see that's quite seasonal. So you have peaks during the day where your cluster is being hammered, and then there's other times of the day where it's doing nothing. So what do you do? How do you scale this? Do you scale for that peak workload, or do you scale for the average? I think it's really going to be up to your requirements on the data. So I've done this myself many times. I've put Kafka in front of Cassandra, and I have all my writes go through Kafka, and they get synced to Cassandra, and it works fine, and it's a fantastic thing. I found on experience is usually the reads that is usually what I'm because writes are so efficient with Cassandra. It's usually the read type of queries, so that approach wouldn't solve you reads. But yeah, I think Kafka is a common one. Other things in there to really act as that buffer, if you will, and avoid you. But you need to add up is putting a Kafka cluster more than just adding another node to my Cassandra cluster, etc.
Great. Okay. Well, there we are, Sander. Hopefully that's answered your question well, and anybody else that was thinking similar. We actually have another question that's come in here from Sai. It says, what are the measures to take care while initiating Cassandra repair to sync some medium cluster consisting of 15 to 20 nodes?
Not quite sure I understand that question. Do you want to?
Yeah, so what are the measures to take care while initiating Cassandra repair to sync some medium cluster consisting
Okay.
of 15 to 20 nodes?
I mean, it's going to be the impact of running the repair, the load it puts on your cluster. So the last time it was repaired, that's so first one is capacity. Can you actually repair your cluster? Do you have enough headroom to repair it without impacting your application queries? The second consideration, if you've not been repairing your cluster regularly, is nodes being out. If you had nodes out for longer than the GC grace period, you want to be careful on that because you'll get zombie data. You shouldn't be bringing them back in.
Mm-hmm.
You should, I mean, you should be repairing on a regular basis. It shouldn't be something you're doing exceptionally. You should be always running. I'd encourage you to look at AxonOps' adaptive repairs tool to repair your data kind of in the background all the time. And there's an open source tool called Reaper, offers similar functionality as well. But yeah, you should. I think the impact should be you should be repairing your cluster all the time.
Okay, great. Thank you for that, Johnny. And also thanks for your questions. Keep them coming, everybody. Keep the questions coming in. Hopefully we'll have a little bit of time later on to look at one or two more. But Johnny, it's part two. We've got 3 parts, haven't we? But we're on part 2 now. So do you want to take us away and tell us more?
So we've talked about your data modeling. We talked about various aspects of your queries. I mean, it's not it's a big topic. It's not comprehensive, but what to take away from that is the gist of the modeling, the partition key, the clustering column, trying to get things to fit nicely in there to support the queries you want to run, and don't be afraid of denormalizing in there. But there's you do all that, but there's also the application driver that you use to connect to Cassandra. Now, the thing to point out, I mean, the Cassandra Java drivers, they're pretty much in most languages. They behave very similarly across them. The principles you learn in one version of the driver language are typically the case in the other ones. There's drivers in Java, which typically seems to be the most up to date. There's C++, there's Go, there's Node, there's everything out there, I think, and Spark as well. But they all kind of do roughly the same thing. I will focus on Java because why not? But don't think just because it's been expressed in a Java code snippet, it doesn't apply to the other language you're using. So core driver concept. So one of the important thing to get your head around is connection management. Now, this is one of I have actually seen this a lot. I had a recent cluster where we had something like 15,000 plus native connections per node in a cluster. Yeah. So, and it's completely unnecessary. So the Cassandra protocol that you use to connect to is not like other databases, okay? When you connect to, say, Postgres or MySQL or Oracle, what you're doing, it's like an RPC call. Your application takes that connection, executes the query, keeps that connection, does it, and then releases back. And you have a kind of a connection pool running in your app, looking after those connections, keeping them up, prefetching them, all that good stuff. You don't have to do this with Cassandra. And I've seen places where they've put a connection pool implementation on top of the Cassandra driver doing this, and it's been horrendous. So just don't do that. Let the driver manage it all for you. And the important thing is you don't need the protocol it uses to connect to Cassandra is really, really efficient. It opens up a socket, and it essentially multiplexes requests over that socket. And it can be multiplexing, I think it's something like 60,000 concurrent requests over a single socket. So you don't need 100 connections to the database. You need 1, maybe 2 from the driver. And it keeps that alive, looks after, etc. So important thing to see, check in the application. You shouldn't need a lot of connections in there.
Hey, Johnny, just to quickly say, we want to make sure that we've got enough time to complete all the sections here. So
I'll
we're a
speed.
few minutes behind, but I know you're on it, and there is a lot to cover. But it's all good.
So it looks after your sessions, your query execution, and is load balancing and retry policies. Load balancing policies are to do with the choice of coordinator to service a request. You can choose different ones. Token aware is the default. There are situations where you might not want to use token aware load balancing, where you maybe have a hot partition, so you might want to just do round robin of the requests around, but you choose load balancing policies. What you don't want to be doing is too many connections to the database, as I mentioned. So this example here, you can see me connecting and creating a session on every function. This example here, I have a long-lived session and I reuse that across sessions. So that's what you want to be doing. The session and cluster, they're long-lived objects. They're intended for reuse. You throw them around your code. Not marking queries as idempotent is another issue I see more frequently, because they kind of change the behavior. But essentially, Cassandra has retry policies, but it will only retry a query if it is marked as idempotent, which basically means if I retry it, it's going to yield the same result. What you have to do as a developer is you have to explicitly mark your queries now as idempotent. And if you don't do that, when it's valid for the driver to retry your query, it won't. So you lose out on that performance benefit. So maybe your query is idempotent, make sure you say set idempotent true, or you could set the default to be true. Now there's operational considerations as well to think about here when you're designing your up. First one is compaction, and no talk on Cassandra would be incomplete without compaction, but this is not for here. But the point is, there are different compaction strategies you need to decide on what to use for your table, which are appropriate for the workload. Size tiered, level compaction, time window compaction, and in Cassandra 5.0, they've introduced a new compaction strategy, unified compaction strategy. But I won't go into these, but have a look at them, understand why you would choose one over the other. Monitoring is really important. The things you need to be monitoring for all this stuff is at the node level, the latencies, the heap, the GC, at the table level, your partition sizes, your SS table counts, cache hit rates. But the things you need to be looking for, which are monitoring, is if you start to see repairs struggling, increasing read timeouts, you'll see large partition warnings in the logs, heavy GCs, backlogs on compaction, etc. So these are warning signs that something might not be all right. Important to call out a great new feature that's coming Cassandra 4.1 and above called guardrails. This is a piece of configuration in the database that you can essentially disable developers' ability to do a lot of those bad practices in there. So it's a very extensive framework. More guardrails are being added. You get back a warning or an error, and also just logs for things that are maybe, say disk utilization or something like that. But you can see the kind of variations in guardrails. There's stuff to watch for partition size, the number of indexes on a table, the number of views, etc. So as a DBA, you can actually lock down your cluster now with Cassandra 4.1 and above to stop a lot of those bad practices being possible. In there. So conclusion, key takeaways. As I said, critical success factors are your data modeling. Got to get data modeling right. Same with all databases. Configuring your driver. Make sure you're monitoring things. If you're not monitoring, then you're not going to know if you're having issues. And start using guardrails. Yeah, start enabling them, putting in them, turning off those best practices. There's common anti-patterns to look out for, and best practices are model your queries, watch for the partition size, make sure you pick appropriate compaction, and make sure you configure the driver accordingly. There you go.
That's great. That's really, really good, Johnny. Lots and lots of information. If you've got any questions, keep them coming. I do know that we want to get straight into Workbench. We've mentioned it a couple of times now, Johnny. Do you want to just take us through some aspects of that, and how can it really help our audience?
Okay, so let me. As AxonOps Workbench. You'll find it on our website. AxonOps Workbench is a open source desktop client for developers and DBAs. So it is a application you download and install, and using that you can connect up and interact in a cool desktop application for Cassandra. Now, it's completely free. It's completely open source. It's going to be available in the Apple App Store and the Windows App Store soon. Right now, if you wanted to install it, you've got to go to the project on GitHub, and you'll see under releases the release, and then you can pick the appropriate version for your thing. It's still in early releases. It's stable, but we're bringing in a lot of features over the coming weeks. But by all means, please weigh your feedback. We welcome people raising issues. If you want to have any play, bug reports, feature requests, if you want to discuss new features, avenue discussions, and if you want to play in the project, please let me know. So let me show you the desktop application for you here. Okay, so once you install and launch AxonOps Workbench, can everybody see that? Yeah.
Yeah.
We have this a bunch of concepts. We have this concept of workspaces. A workspace is a folder on the file system that contains a bunch of configuration files for different clusters you connect to, and their connection information. And these configuration files are intended to be checked into Git or source control and to be shared between teams. So the idea is you can go in and create a workspace, create all of the different connections to your dev, your stage, your production, check that configuration into Git. One of your colleagues can check it out, import that workspace, and then all the connections there. So you're not having to trial around wikis, etc. Security-wise, we obviously don't store usernames and passwords in that configuration file. If you put them in by mistake, we will fail the connection. We won't even use it. We store everything securely encrypted in the OS keychain as well. But basically, you have workspaces. You go in there and you create connections to clusters. So here's a cluster where I'm connected up to, and you connect up, you see the usual things you'd expect to see. Here we have the details of the node I'm connected to versus Cassandra in there. We list all of the key spaces, the tables, the columns, the partition keys, all that good stuff. You can search through the tree for things as well. And then we have a bunch of features in there. We have this new CQL session. So we've basically built a new if you know what SQLSH is, it's essentially an update to SQLSH, if you will, that allows you to do a lot more stuff than we can do through the command line tool SQLSH. So things like I can export these results to CSV, PDF. I can search in the results that have come back. We also have enhancements around query tracing, where if you run a query with tracing enabled, you can look at the trace and see all of the steps that were taken to execute the query against there. And so that should really help with debugging bad queries in there. You have the ability to explore your key space, so you can right click on get the CQL descriptions of your tables and key spaces and things like that. And the idea is that you would go in to there, create a workspace, create all the different connections in there. When you're adding connections, we support SSH tunneling as well. So you can actually connect to your Cassandra cluster over SSH, and we also support you connecting through a Bastion server SSH as well. And you can set all that up there when you create your connection. Other thing we have is this concept of local clusters. You have the ability to start up running on your local machine different versions of Cassandra. So you would basically go in, add a cluster, say, I'm going to install Cassandra 5.0. I want to use, I don't know, let's say 3 nodes. Now, what we do is we use a containerization to start up on your host machine, and you need to have Podman or Docker installed. I like Podman, it's Apache license, I think. And then you click create local cluster, and then it will essentially click there, and then you can start that up. So I've got a few started up already. So let's go into this one here. So you can see what you see when you have the local cluster there. So it looks very similar to what you're connecting up remotely, but we give you a couple of extra things in there. So you have the same SQLSH terminal. Oh, I forgot to mention, by the way, if you don't like the enhanced terminal, you can toggle back to the traditional SQLSH terminal. So we're not going to force you, but you can switch between the enhanced console and the traditional one that you might be more familiar with. But we also have a bash session to create on that cluster. And then if you choose so, you can also install AxonOps locally and have all your kind of dashboards, etc., deployed next to your cluster. Other things the app has, it's experimental. It has an AI chat in there, and this is a RAG application we've trained, built on top of Llama 3.1, and you can use that to ask questions about Cassandra, etc. So, what's a static column in Cassandra? It will go off and look at what we've trained it with and bring you back an answer to that. Things to point out: you'll have to sign in to AxonOps to use the AI assistant. But yeah, you can use it in there. But as I said, it's experimental, but it should be, and as you can see, it's giving you good answers there. So there's extra features as well. So the configuration you set up when you're creating connections, yeah. If I show you a connection here, so let me look at that setting. Oh, I can't do it because it's active. Essentially, when you create a connection, yeah, you can add variable names to be substituted for you in any of the connection details, yeah. And also, if you switch the editor, it should look like SQLSH, which should be quite familiar because it's based around that. But essentially, if you wanted to share some configuration, rather than hard coding a host name, if you will, what you can do is you can go in and you can just define variables and reference those variables, and they'll be substituted for you. So you can check in the configuration that has the template, and then when you load up that connection in there, it will substitute for the variables that you've defined on your host machine to replace them in there. And there's scope to these variables as well. They can be workspaces, every one of them, or to a specific workspace in there. There's features around security and logging. I won't turn it on, but we also have the ability to enable DRM. So you can't screen share Workbench, which is sometimes needed for sensitive environments where you don't want to allow people to screenshot what's coming back, and you can have logging. We support multiple languages in there, and you'll also automatically check for updates. So there you go. That's Workbench in a nutshell.
Fantastic, Johnny. Really good. And you've been an absolute star today, going through such a lot of information there and finishing really well with a fantastic demo there on Workbench. So hopefully this is really helping you, audience. So we've still got a really good number with us, which is great. And there's been people coming in as we've been going. So if you've not captured the whole of the webinar, we will have a recording. We'll make that available for you. There's also a few other important notices to really give, and we have talked a little bit about AxonOps and Workbench and some other areas. If you want to go and check us out, maybe try us out even, you can attach up to 6 nodes, and you can do this for free. And we've got the QR code there for you to be able to do that. And of course, there's a link as well for Workbench we've demoed for you today. A lot of people have lots of questions, and they're quite particular, quite individual, aren't they, Johnny? You know, focused on their particular environment. What we've done is we've set up a book an expert session. So what this does is it allows you and your team to come on and talk to some of our experts, and Johnny is one of those. So if you did want to talk about your own particular environment and situation, and maybe some areas that you want to drill down a little bit more, it's a really good opportunity to do that. It's absolutely free, complimentary from AxonOps. Just click on and you can book a session in. Choose the time that suits you, and gather some more information. And of course, we are continuing our masterclasses. We've got this one now and another one that you can play on demand, and we've got a link there for you as well. The next masterclass is coming up on the 23rd of January. I will be back with a couple of Cassandra masters, and I think we are sharing now who they are. One is John Haddad, and the other one is Jordan West. So I'll let you check them out. There's going to be a lot more information on that. The registrations, the invitations will be going out soon. Registrations will be set up shortly. We're just finalizing some of the information around that, but very, very excited. That's happening on the 23rd of January. We will be sending you all of the invitations out as soon as we've got that up and running. We've got a couple of minutes left, Johnny. It's been a fantastic session. Hopefully you've got across everything you have. I think you've done amazing there in less than an hour to do all of that. Is there any final comments or thoughts that you would like to make before we finish up today?
Yeah, just keep it simple. I mean, you don't have to overthink it. The data modeling, the principles of it are very simple. So if it clicks, hopefully it has clicked, and if the basics around partition keys and clustering columns, if you've come away with that, then just remember that when you start looking at different use cases, always take that in mind.
That's great. Well, Johnny, thank you for being our Cassandra master today. I really appreciate that. And of course, thank you to audience for joining us and for your questions and input. We hope you've really enjoyed the session today, and we hope you'll be back with us again on January the 23rd. Until then, take care, stay safe. And from all of us here at AxonOps, have a very happy Christmas and New Year. We'll see you soon. Thanks very much. Take care. Bye.